Live from Earth, it's Space Radio. This is Paul Sutter, and coming up, whatever that NSF press conference was about, goodnight, sweet Kepler, and flights of exoplanetary angels, sing thee to thy rest. And I swear this time I'm going to talk about the cute baby planet with the picture, and of course, taking listener questions about all things in the universe. We record every Thursday at 4 p.m. Eastern. Call 888-581-0708 to join the conversation. And in today's Blue Shift, I'll be talking about a science and dance extravaganza. But first, the news. Hello, space fans. Welcome to Space Radio. I'm Paul Sutter, astrophysicist at Ohio State, chief scientist at CoSci. For the next half hour, your agent to the stars. In this astrotherapy session that we all know and love, got an exciting show for you today where we talk about everything in the universe. This show lives on listener questions. We record every Thursday at 4 p.m. Eastern here in Studio A of WCBE Radio Columbus. It's called 888-581-0708. Light it up. You can also follow along on our live streams on YouTube and Twitch. Go to spaceradioshow.com for the links where you can join the Space Cadets watching the live stream right now from London, UK, Kabul, Afghanistan, Lancaster, California, Hutto, Texas, Tenerife, Spain, Linköping, Sweden, Seattle, Allentown, Pennsylvania, and more from around the world. Seriously, folks, I've prepped basically nothing when it comes to this show, so get those calls and questions in. Before I start taking questions, I wanted to share the big deal just dropped today. We're recording on Thursdays, and it happened Thursday morning. This is a story where there's so many cool aspects to the story that I don't even know where to start. I can't pick. Here's the rundown. We have a neutrino observatory in Antarctica, and there's a lot to unpack even in that sentence. It saw a really, really powerful neutrino. There's a lot to unpack in that sentence. Coming from a galaxy 4 billion light years away. Lot to unpack in that sentence. We think now, based on this one neutrino that we saw that was slamming into the ice of Antarctica, that we think we have confirmed that giant black holes are the source of cosmic rays. How many times? How many jargon words can I pack into a single sentence? That may have broken the record, folks. That may have been it. First off, we have telescopes at the South Pole, because why not? And one of these telescopes is actually an instrument where we're using a cubic kilometer of the Antarctic ice sheet itself as a detector. It's a big block of pure water. We have detectors strung down into the ice, and we're hunting for something called neutrinos. Neutrinos are like the ninjas of the particle world. You don't even know when they're there. There's probably a dozen ninjas in this room right now as I record. I can't even see them. And there's a lot more neutrinos. Neutrinos come about. They are created in nuclear reactions. So when you can see them, when you do have that lucky chance observation, you get a window into deep nuclear and atomic processes, high energy processes in our universe. So nuclear reactors make neutrinos, our sun makes neutrinos, but these are relatively low energy neutrinos. And I had a question already before the show even started from Puny Gods over on YouTube asking how energetic was this neutrino that they caught. Had an energy of 50 tera electron volts, which means absolutely nothing to most people. To put it in terms, our most powerful particle collider, the Large Hadron Collider in CERN, Switzerland, or at the CERN facility in Switzerland, this one particle that originated 4 billion light years away is 50 times more powerful than the world's most powerful particle collider. Nature is super good at making really fast, high-energy particles, and every once in a while we get to see them. In this case, we saw one, and because the Ice Cube detector, which, by the way, is the name of this observatory in Antarctica, it's called Ice Cube, it's a joke. Because it's a three-dimensional detector, we can reconstruct where this neutrino came from, and we pinpointed, traced it back onto the sky, and then we brought in a bunch of other instruments to look at that part of the sky, and we saw a flare. We saw a distant galaxy flaring up in many, many different wavelengths of radiation. So something funny was happening in that galaxy that generated a lot of energy. Amongst the things that it generated was a bunch of neutrinos, high energy neutrinos. Some of those neutrinos passed through the Earth. One of them passed through our instrument at just the right time. There you go. Powerful neutrinos from across the universe. By the way, live streamers, space cadets, little bit different setup. I'm in the same studio that I'm in every time, but WCBE 90.5, they're having a community garage sale as a fundraiser thing this Saturday, and this room is the dump. I'm pretty sure this is what Greg's house looks like. He gives off those kind of hoarder vibes, and so pretty much it's just Greg just offloaded some of his memorabilia and shoved it in the studio, and that's pretty much that is the event. So if you have questions about the topic that I'm talking about, this whole neutrino detection, there's a lot I didn't get into if you want to ask about that, but we do have a caller. So I'll do this next segment with the caller. We've got a caller first. Hey, Jack. Thanks for calling Space Radio. Where on Earth are you?
I live in Celestial Village in Idaho.
How appropriate of a name of a town. I love it. What are you curious about today?
Well, I'd like to hear how you contrast parametric time with respect to physical time.
Mm-hmm. Yeah, this is a really great question that digs into the mathematics of special relativity and general relativity. We're used to thinking of time as just, time. Like time, it just happens and it's no big deal. And we're used to the idea that everyone agrees, that everyone has the exact same clock, that I have a clock on my wrist, there's a clock in the back of this station, there's a clock, hanging out in the middle of the Andromeda galaxy, and all clocks are universal and all clocks are synchronized. This is the old school way of thinking. I wouldn't blame you for imagining that there's some sort of universal time across the whole universe. This view is also dead wrong. This is something we realized in the early 20th century with some very careful experiments regarding the speed of light, the development of Maxwell's equations, understanding electromagnetic radiation, leading up to relativity. Einstein's first baby, genius baby, special theory of relativity, where we finally understood that no, clocks are not synchronized across the universe. A clock on my wrist is different than a clock up in orbit, which is different than a clock in the Andromeda galaxy. Different observers have different rates of time. This is a fundamental aspect of our universe. And these different clocks tick at different rates depending on how fast you're going, depending on how strong your gravitational environment is. All sorts of factors change the rate of ticking clocks. And we've been able to measure it. It's the most ridiculous thing because it's just, you can just say this like, oh yeah, clocks are different across the universe, but this is science. We actually have to prove stuff in science. We need evidence. We need experiments. We need to verify things. And we've measured it. So we've put atomic clocks in airplanes. We put atomic clocks at the top of tall buildings, and we can measure differences in the rate that they tick. It's super small because the gravity differences around the Earth aren't that big. And we can't make our jet airliners go that fast. So it's a tiny difference, but it's a measurable difference, which is the most important part. Now that there are different clocks and different observers will disagree about the duration of events. Like I ran that race in 5.5 minutes. And then the referee will be like, no, it took you 4 hours. You walked. And I'll be like, no, wait, we disagree. This is a relativity physics thing, not just a lazy out of shape thing. And because different observers have different clocks, we need to distinguish in the mathematics. We need to keep track. We need to label the different clocks and how they're keeping track of their own time. So there's various words you might encounter on, say, Wikipedia articles or descriptions of relativity. There's physical time, there's parametric time, there's conformal time, there's proper time, there's all sorts of definitions of time, and it really boils down to what different observers are going to count. At the end of the day, our mathematics are all consistent. Different observers will disagree about the duration of events. That's fine. There's other things that they will agree on. There are other things that observers can measure that everybody agrees on across the universe, but time is not one of them. Jack, did I answer your question? Do you have any follow-up questions based on that lovely introduction?
Yeah. The uniformity of parametric time is uniform. The first interval of parametric time is the same as the last interval or the middle interval or in intervals between them. That's what makes parametric time useful for measuring other phenomena that change.
Right. So there's different ways we can divide up time. We don't always have to use seconds that count by each other uniformly. We might be interested in physical processes that, say, get faster and faster or more energetic as time goes on. And then it makes sense to chop up time in a different way so that, our buckets look pretty even and our graphs look nice and pretty and we could fit everything on the same page. And this is mostly, I don't want to call it a trick, but it's a convenience. It's a convenience so that we can make sure everything is nice and even and harmonious. There we go. That's a great word to use. Harmonious. Thank you, Jack, for the wonderful questions. It's about time for a question about time. Don't you agree? And it's about time to give a shout out to our sponsors, which is you. Go to patreon.com/PMSutter to learn how you can support this show, which the name of the show is Space Radio. The name of the host is Paul Sutter. And the name of the supporter is insert your name here. I'll see you after the break. Yeah, community grog sale. That's a different thing. That's right at Greg's house is the grog sale, Rinstro. Dr. Naminsky, how do we detect neutrinos? Good one. Oh, by the way, Nancy, the WCBE Cosmic Cookout, that's Friday night, that's sold out. It's done. We filled it up. So if you're interested in going to the Cosmic Cookout, too bad. You're going to have to wait till the next one. Tons of great questions. So I want to keep following. Let me see. Legion 54, do neutrinos have any adverse effects on the human body? No, not really. I can dig into that a little bit more in the next segment. And then someone else asked a neutrino question. Sorry, you guys, I like you chatting, but then I missed a question. And David Abbasi, how are we sure it's a neutrino from a black hole and not another source? Okay, so I'll dig into the physics of this the neutrino detection and the source and all that in this next section. That sound good to you? I don't care because it's my show. Welcome back, everyone. I'm Paul Sutter, and this is Space Radio. We've got some more listener questions ready to go. But remember, you can join the conversation by calling 888-581-0708 or by following the live streams over on YouTube and Twitch. Go to spaceradioshow.com for the links. There's a great question from Rinstro watching over on Twitch about fundamental constants of nature. And do they change? Is that a thing? Are people paying attention to this? Does anybody care? There's a few constants that you can name that seem kind of important. like, say, the speed of light, or the charge on the electron, or the fundamental unit of angular momentum called the Planck's constant. There's a few, the amount of dark energy in the universe. There's a few numbers, and depending on how you divide it up, between 1 and 2 dozen numbers that just appear in physics, and we have no explanation for it, and that's a whole other show. But there's a question, are these constant really, really constant? Or do they change with time? Do they change with space? Is there anything there? And you can develop exotic theories of how the universe works where the constants only appear to be constant because they change very slowly with time. And if we look back in the distant universe, it might operate differently because, say, the speed of light is different back then, or the fundamental electric charge is different back then. We've looked, we've checked, we ain't found nothing. So we're not exactly sure where to go from there. It appears that our constants of nature are truly fundamentally constant, at least on all the time and energy scales that we've checked, which is a lot. That doesn't rule out that in some exotic phase of the extremely early universe, there might be some different rules apply, but we see no evidence of it yet. But it's still one of those things that we keep in the back of our minds, like, we're bored. I know. Let's check to see if any fundamental constants in nature have changed in this data set. And then we look and we don't find anything, and then we go back and do something else. And one of the ways we can probe the exotic universe, the high energy universe, is through these neutrinos. And David Abbasi over on YouTube, one of the space cadets, is asking, are we sure this ice cube neutrino Antarctica experiment that saw one neutrino, how did we know it came from a black hole or not another source? Like, just how do we know? We know because we traced back its path to a particular point at the sky, and then we pointed other telescopes at that same point in the sky and came out with something really surprising. We saw what we call an active galactic nuclei, aka a quasar, aka a blazar, aka a really, really bright thing very far away. And it's through this process of what we call multi-messenger astronomy that we were able to deduce the origins of this neutrino. And this is something that you're going to see coming more and more as the years go by, where there won't be just an announcement from one observatory or one team where they're just saying like, oh yeah, we saw this thing, it's really cool. When do we get that trip to Stockholm for the Nobel Prize? No, it's going to be teams. It's going to be multiple observatories using multiple ways of viewing the universe. So not just the classic electromagnetic spectrum, visible and infrared and ultraviolet and X-ray. There's going to be neutrino observatories. There's going to be gravitational wave detectors. There's going to be cosmic ray observatories, all working together literally across the globe, that when one instrument triggers on an interesting event, a bunch of others follow together and point at saying, hey, what's going on over here? And we all look, we all take a picture, we all collect data, and then we can compare notes and we can build a complete picture of this event. So you're going to see over the next few years more and more of this, what we call multi-messenger astronomy, paired with something else that we're calling time domain astronomy. Short-term events, little bleeps and bloops and flares and whizzes going on in the sky. You're going to see those happen with more instruments trained on the sky, observing simultaneously. You're going to see this more and more, where there's more interesting things happening at short time scales. Great questions over on the YouTube. Remember, you can call 888-581-0708 to join the conversation on this show known as Space Radio. Now, there's another question on the YouTube. I lost track of who asked it. I'm very sorry. The chat just streams by, and it's too fast for me to keep up, man. Just like it takes me 4.5 hours to finish the race. There was a question about, do neutrinos, are they harmful? Should we be worried about them? Check this out. This is one of the most fun numbers that I like tossing out. If you take your thumb, Take your thumb and point it at the sun. You can look at your thumbnail and your thumbnail covers up a certain area. So there's light hitting your thumb, and there are also neutrinos hitting your thumb because neutrinos are produced in nuclear reactions. The sun is a giant nuclear reactor, so of course it's going to make a couple neutrinos. How many? Well, in the area taken up by your thumb, there are 60 billion neutrinos passing through it every single second. I'll say it again because that's a fantastically large number. Every second. 1, 2, 3, 60 billion, 60 billion, 60 billion, 60 billion through your thumbnail all the time. Multiply this by the surface area of your body, which may not be a large number. It may be a very large number. I'm not going to say, but it's some number. There are a lot of neutrinos passing through your body right now, but they don't interact. They are stealthy. They are ghosts. They are ninjas. The only way they interact with normal matter is through the weak nuclear force. And the weak nuclear force, as you might have guessed from its name, is super weak. It's hard to interact with the weak nuclear force. It's very lucky, very chance interaction. So the neutrinos just pass on through, man. Just sail through, hardly notice us. We hardly notice them. We didn't even know they even existed until the 1940s. We went millennia of human existence without knowing that these neutrinos were passing through us. So are they harmful? I suppose if you got exceedingly unlucky, a high-energy neutrino might strike, say, a strand of DNA, cause a chain reaction, disrupt that chain of DNA, lead to a replication error, which would lead to cancer, and that'd be a bad day. You might have to wait longer than the universe has existed for that chance interaction. So I'm going to go ahead and say that neutrinos are going to be safe, that the state of California doesn't need to post a warning label about it, that we can pretty much ignore neutrinos. We're good. There are other things that are going to get us. Ultraviolet radiation gets us, cosmic rays get us, but neutrinos, we're good. Flooding through the universe, that's why we need a cubic kilometer of ice in Antarctica to even catch a glimpse of these every once in a while. And think about it, this particle that the collaboration saw, they saw one. They've been operating for a decade. And they see a lot of neutrinos, don't get me wrong. They see these high energy neutrinos extremely rarely. So go ahead. One less thing to worry about, neutrinos. Got 99 problems, but neutrino ain't one. Oh, I crack myself up when I'm recording these. Yeah, if you were allergic to neutrinos, that would suck. You would get hives and swelling in like every place. It'd be pretty ugly. Have you guys, can you see some of the stuff back here? I'm taking a little break before I do the blue shift. There's some patriotic, it's all categorized. There is some patriotic swag, like flags and this thing. There's a glass. Anyone want to buy a glass? That's 50 cents. That's 50 cents. That's from Greg's collection. What else do we have here? We have miscellaneous small items over here. Look at that. Art makes C-Bus. Fans, we're big fans of art. Get it? There is a mystery bag labeled Samsung. What are these? Are these like 3D glasses that you're supposed to go with something else? Someone tell me. I have no idea. All right, I'll wrap the show. Fine. I'm Paul Sutter, and you're listening to Space Radio, and this is the Blue Shift, my opportunity to get a little bit closer to you. First, a quick note about the Cosmic Cookout. If you're listening to the recording, the live stream, the Cosmic Cookout is tomorrow. If you're listening to the broadcast on air or as a podcast, the Cosmic Cookout was in the past. Either way, you can't go unless you already have a ticket because it was sold out, or because it happened in the past, and time travel into the past is not possible as far as we can tell in our universe. So I'm going to go ahead and call it and say it was an amazing time. We had lots of fun. We had great food, lots of science, some awesome stargazing at the John Glenn Astronomy Park. We'll try to do one again because this was kind of a success, and I guarantee it was lots of fun. Speaking of events, if anyone is in New York City on Wednesday, July 18th from 6 to 7 p.m., I will be at the Open Wine Bar. Hey, that's kind of cool. Over on East 3rd Street, I'm doing an event with Siren Modern Dance. They're a modern dance company. I've been working with them for almost a year now of developing a very cool collaboration, and this is kind of a launch party for a new project that we're calling TikTok. It is exploring the nature of time through both science and dance, so perspectives on time, communicating time, how we perceive time. So it's a summer soiree to celebrate science, dance, and time. That's in New York City, and so feel free to come. It's a free event. It's tons of fun. I'll put a link in the show notes where you can register over on Eventbrite. Here's the thing, why am I doing a thing with dance? I'm sure you've heard me talk about it before, and of course I'm going to talk about it more and more. In case you haven't noticed, I enjoy talking about science. I enjoy talking about the way the universe works. I love sharing what I know and what I love about the universe, and I will do that in any way I can. I love exploring ways to communicate these fundamental concepts. I love exploring ways to share my perspective based in physics, based in math, on how the universe works without using physics, without using jargon, without using math. I think dance is a wonderful way to communicate essential concepts and just express yourself and be inspired by this awesome science and communicate that. And then at the end of the day, you can go to a performance, you can see something where it was a beautiful dance performance, and hey, you happen to learn a little bit about the way the universe works. So that's why I love doing all of these science and dance collaborations and science and art collaborations. And I'm cooking up another one with Siren Modern Dance over in New York. So go to spaceradioshow.com for the links so you can register. It's a free event. Isn't that great? And unfortunately, this broadcast is almost done. Thank you for joining me on this voyage of space radio. Once again, I'm Paul Sutter, and this show is brought to you by the Ohio State University Department of Astronomy. Learn more at astronomy.osu.edu. This show is also brought to you by you. That's right. Can't ignore you. Go to patreon.com/PM Sutter to learn how you can contribute. Thanks to Greg Moebius for producing, Dan Michalka for being awesome, and all the fine crew at WCBE Radio for making this show possible. We record every Thursday, 4 p.m. Eastern. Call 888-581-0708 to join the conversation. You can also join the Space Cadet crew over on YouTube and Twitch. Go to spaceradioshow.com for the links. You can also follow me directly on all social media channels at Paul Matt Sutter. And of course, thanks again, Earthlings, for listening. See you next week. And remember, science is for sharing. End of transmission. Thank you, Kate. By the way, everyone in the chat, user Mama Kate St. Amand, she is the artistic director, I believe is your title, of Siren Modern Dance. She will be at the event too because she made the event happen. So she'll be there, and she's great, wonderful dancer. Her crew, her dance company is fantastic. I love watching them work and creating stuff with them, and I can't wait to get this collaboration going. And don't tell Greg, if you want to buy any of this stuff, I'll sell it to you right now. Send me $10 on Patreon, and I will give you a random thing from the pile here. I might give you one wine glass. I might give you a fake flower. I might give you... Oh. I don't know which one of you lucky ducks will get this. I will get you a poster of frogs. I'll do it. Give me $10 on PayPal. I'm joking, actually, because this isn't my stuff. It's WCBE's funders. But you could have a poster of frogs. You could have... This is a gold mine. I will give you... Greg is giving me something to give you. Health and physical fitness, because it takes me 4.5 hours to do a race. Look at that.
From the 1940s.
From the practical, scientifically speaking, folks. Occupational disease, dermatoses, occupational dermati, primary irritant, that's Greg. Dust count, asbestosis, these workmen's compensation laws. I will give you this book. I'll give you this book. What else will I give you? There's so much good stuff here. You want another book? Generation T. 108 ways to transform a t-shirt. Look at that sassy lady. Look. It's bookmarked. Someone went through and picked out their favorite ideas. What was there? A rollover. Someone's favorite idea was a rollover. I could do this for hours. This is hilarious. It's a cinch. This is a cinch. Generation T, 108 ways to transform a t-shirt. Could be yours. I want this. You guys don't get this. The Far Side Gallery. Oh, man. I love Far Side growing up. I'm keeping that. I'm not giving that back. There's more stuff here. There are Taekwondo gear bags. Who wants a Taekwondo gear bag? You know what to do. I wonder, would that work as a fundraiser? Obviously, it works for WCBE. Like, if I gave away random stuff of mine that I don't want anymore, and I mailed it to you, and then you gave me money to help support all my outreach and education. There are lots of ways to transform a t-shirt. What is this? Ladies and gentlemen, false eyelashes. What do you guys think? What do you guys think if I did the false eyelash thing? I mean, I'm pretty sure I have decent eyelashes as it is.
This.
What is Greg bringing me?
What do you think this is?
Skipping this. Ooh.
So you'll never guess.
I'll never guess. Is it wait, there's a
Yes,
plug.
there is.
There's a plug. Guys, look at this. There's like a carving, like an ivory carving of a dog hunting a pheasant. Something. And there's a plug, like a very, very old plug. This is great. This is way better than sitting in traffic, which is what I was playing.
Four-prong plug.
Four-prong plug. I'm going to open the box. Should we open the box?
You'll never guess.
Greg's, I'm not even going to bother guessing. It's a phone. It's a phone. Look at that gorgeous phone.
Old school.
That is glorious. Look, rotary, but on like a
dial.
And if the top wasn't all cracked, you could get.
Oh, absolutely.
I would take that to a consumer.
Megabucks.
Absolutely.
I love the sound of a rotary phone. You like that?
See, we're the last generation to know that.
Wow. It doesn't work though. I'm not hearing anything.
No ET?
No ET. That is glorious. What a phone.
Yep.
How does it, like...
Well, there's not even an electrical...
No, so the four-prong must be both...
Yeah.
Or it just gets power from the phone line. So is this like an old school...
I'm so young, I don't remember that type.
Don't lie, Greg. Don't lie. We've got cassettes. Guys, I will be here forever. There are a lot of phone cases for phones that nobody owns anymore. You've got this one. The Jaguar. At the beach, R.I.P. Kate Spade. Bet you didn't see that coming. Camouflage. Classic black. Engineer. Retro wood. That's an interesting one. Sensible leather for the mature.
Wow.
Phone holder. There you go. Or you can have all of them for like a penny. Wow. This place is a gold mine. Can we make this like the permanent studio and you just rotate in new surprises? And that'll be the way I end every live stream is digging through here.
Selling some stuff.
Yeah, selling stuff.
Keeps the show on the air.
I would do it. This is great. One more thing. I want to get up because I you can't see everyone, but I'm surrounded by things. I want to get up and I want to pick something you'll really like. This one's for you, Yamagishi-san. I think I know what kind of person you're like, and you're gonna appreciate this. This one's for you. I want you to own this giant wreath. This is for you. $10. $10 and it's yours. Take it. I want you to take it. I thought of you. I saw that at the beginning of the show, and as soon as you came online. A cool cube for neutrinos. Love the title, Astro B. That's what it's going to be.
Neutrinos coming back.
Is a neutrino its own antiparticle? We honestly don't know, actually. We think they might be, but there hasn't been any conclusive evidence one way or the other. So we don't know if neutrinos are their own antiparticle. I remember rotary phones. We had a rotary phone in my house growing up. Ooh, ice cube, not just for cooling an adult beverage. I think I'm going to go with Astro B. Oh, do I have any ultra high energy neutrinos?
Yes.
That's a great joke. That is a great joke.
Your day without a big old bowl of neutrinos. Yes.
Neutrinos, like Cheeto pants. He doesn't know.
Neutrinos is a variation, and it's fortified like vitamin A and D.
What is it fortified with?
Vitamin A and D.
Vitamin A and D.
Yeah. Neutrinos.
Yamagishi-san, you don't have a front door big enough? Get a front door big enough. You don't get a choice. Sorry, Ark. 4 p.m. Eastern every single Thursday we record on. Oh, I forgot to tell you. Forgot to mention on the radio. Next week I am recording. I'm filming with the Science Channel Thursday afternoon. So I'm going to do the show, but I'm going to bump it up to 8 o'clock. And I'll put a notice on social media and on the website. And by the way, I'm gone next week. I don't think I told you. I'm in DC next week filming with the Science Channel. And so I'll record the show remotely, but it'll be later in the day on Thursday. Okay. So it won't be 4 p.m. next week. It'll be 8 p.m. next week. I hope. If I wrap that segment with the Science Channel. Which I should.
I'll have a repeat on standby.
Thank you, Greg. Greg will have a repeat just in case I screw something up. But you'd think if I'm able to do a show from Ukraine, I should be able to do a show from DC. A cool cube for neutrinos. All right. Thank you, everyone, for watching, and I will see you next week. Not at 4 p.m. Eastern, but at 8 p.m. Eastern. Neuchitos with dip. Oh, man, Larry, come in the last minute. Neuchitos. Neuchitos with dip. I'm writing it down. Cheetos with, I like the exclamation point in the middle. There it is. Neuchitos with dip. Sorry, everyone else, Larry gets the prize. That's what I'm going to call the episode.